Okay, so example 1, restaurant sales. And I've modified these from the previous video to match the situation where we do not know the population standard deviation. Okay, so to estimate the mean amount spent per customer at a national steakhouse chain, data was collected for 15 customers. So multi-person meals had the total divided by the number of persons to get a per customer meal price. So the sample mean was $4. So sample size is 15. The sample mean was $4. So at 95% confidence, what is the margin of error? If the sample mean was $20, what is the 95% confidence interval for the population mean? So let's do the first one first. So at 95% confidence, what is the margin of error? So we had an N, a sample size of 15, a sample standard deviation of 4, and that means a degrees of freedom of 14. So remember, degrees of freedom is N minus 1. So when we find that in our T table, we find that degrees of freedom of 14 at 95% confidence, or an alpha of 0.05, is 2.145. So 2.145 is the T value for 95% confidence and degrees of freedom of 14. Now to find our standard error, we use the sample standard deviation, which is S, divided by the square root of the sample size. So we know that that is 4 divided by the square root of 15. So that is 1.03. So in our margin of error up here, where we have S sub x, that's the standard error of the mean using the sample standard deviation, we have 1.03. So we can substitute that in to our margin of error there at the top. So now we have x bar plus or minus 2.145 times 1.03. So that gives us a margin of error of x bar, the sample mean, plus or minus 2.21. And that's how we find the margin of error for this type of problem. Now, if the sample mean is $20, what is the 95% confidence interval for that? Well, since our margin of error is 2.21 and our sample mean was 20, it's just 20 plus or minus 2.21. And what we can do is put that margin of error on a distribution curve. So remind ourselves that the sample size was 15, the sample standard deviation was 4, the degrees of freedom were 14, because that's 15 minus 1, our alpha level is 0.05, or you can think of it as a one tail or each tail of 0.025, but the overall alpha is 0.05, and that led to a t value of 2.145. So how do we get that? Remember, we use the t distribution table. So we find the column of an alpha of 0.05 for both tails, or 0.025 for one tail or the other. And then we go down and we look for where that intersects with the degrees of freedom of 14. So those intersect at a t value of 2.145. Now notice where the black bars are there at the bottom. They are at approximately 2.145 standard deviations away from the mean. Now remind yourself, if we were using a standard normal curve and not the t curve or the t distribution, at an alpha level of 0.05, where would those black bars be? Well, that would be at 1.96 standard deviations above and below the mean. So what we're saying here is that even though the alpha level is the same, because we are using the sample standard deviation, we therefore have to use the t distribution. In the t distribution, there will be a curve for each sample size. So for a sample size of 15 and degrees of freedom of 14, the t value is 2.145. So the curve gets pushed outward just a little bit. And of course, it becomes slightly smaller as well. And again, that's just pointing out that because we're using the t distribution, it's going to be a little bit shorter and a little bit wider, even though the blue area is still 95%. Now we can go ahead and put some numbers at the bottom by just doing some addition and subtraction. So 20 plus 2.21 is 22.21, and 20 minus 2.21 is 17.79. So this is our 95% confidence. So what we're saying is that we are 95% confident that this interval contains the population mean. We are not saying that there's a 95% probability the population mean is in here. What we're saying is that we're 95% confident that this interval contains the population mean. The randomness is in the interval. It is not in the population mean. So example 2, customer service drain. So brick and mortar stores like Best Buy, Barnes & Noble, etc. have a difficult time dealing with the practice of showrooming, whereby customers come into the store, examine items, scan them with their smartphone probably, leave, go online, go home, to find a cheaper price online where there's less overhead cost. So you go into Best Buy, you think, oh, that's a nice TV. So you look at it, look at the back of it, make sure it has the connections you want, you look at the model number and everything, make sure it looks how you want it to look, etc. Maybe even take a picture of it with your phone, then you go home, go on Amazon, and find it for 30% cheaper. So stores have this problem a lot. We call these false customers. So sales associates spend time with customers who have no intention of buying anything at the store, which leads to unproductive time spent because you're basically becoming a customer service representative of Amazon. So management in one company determined that if less than 15% of a salesperson's 8-hour day, which is 4,320 seconds, that's 15% of an 8-hour day, is spent with false customers, then showrooming, while a nuisance, is not a major problem. So sort of their point of concern, or threshold of concern, is this 15%, or 4,320 seconds. So to determine if customer showrooming is really a problem, based on these companies' standards of the 4,320 seconds, 30 sales associates are randomly selected to measure their service times with false customers. So for this problem, we're going to use the sample standard deviation, which turned out to be 1,958 seconds. So that's our sample standard deviation. So here's what that sample produced. So remember, our N is 30, so 30 sales associates. Our sample is 3,661.5 seconds. So that is the sample mean. Our sample standard deviation, S, was 1,958 seconds. So we can find the standard error of the mean. So that is 1958, or 1,958 seconds, divided by the square root of 30. That's our sample size. So we have a standard error of the mean of 357.48. Now we can find the confidence interval. So if we go to our t-table and we go for an alpha of 0.05, again, the same one we've been using, and now we're going to 29 degrees of freedom because our n is 30, so our degrees of freedom is 1 less than that, so that's 29. If we find where that column and row meet, that is a t-value of 2.045. So we can go ahead and substitute our numbers back in. So the mean was 3661.5 plus or minus our t-value of 2.045 times our standard error, which was 357.48. So our interval is 3661.5 plus or minus 731.05. So we'll go ahead and put this on a graph as well. So here's our curve. Now if you'll notice, our black bars are pretty much right at 2 because our t statistic was 2.045, I believe. So it's pretty much right on 2. And then there's our margin of error and our interval there in the middle. So we can go ahead and do some addition and subtraction and put in our numbers there on our t-values. So 4392.55 and 2930.45. And again, that's just addition and subtraction. So we say we are 95% confident that salespersons spend between 2,930.45 seconds and 4,392.55 seconds interacting with false customers each 8-hour day. So remember, we're not saying we're 95% confident the population mean is in this interval. That's not what we're saying. What we're saying is that we're 95% confident that this interval contains the population mean. There's a difference. I know it sounds like we're saying the same thing, but those are two different things. So we're not saying we're 95% confident the population mean is in this interval. We're saying we're 95% confident this interval contains the population mean. That's what we're saying. Now, remember our concern point was 4,320 seconds? Well, just using the standard way we find z-scores, and that leaves us with a t-value of 1.84. So we go ahead and graph that using the red dot. Now, notice where that red dot is. It is within our interval. So, our concern point is within our interval. So, what do we conclude? We conclude that false customers are, in fact, draining resources from our associates, and therefore we may need some policy intervention. So, just take a step back and think of what we're interpreting here. We took a sample, and based on that sample size, we found the t-statistic, we found the standard error, and we used that to construct a 95% confidence interval for the population mean of all sales associates. So we went ahead and we found that interval, and then we learned that that interval contained the point of concern that we are interested in. So what we said is that if this point is not within this interval, then we're not really concerned. That means our sales associates we're pretty confident our sales associates are spending less time than we're concerned about. But since this point is in the interval, it would appear that our customers, or there's a very good chance that our customers are, in fact, spending an inordinate amount of time with false customers, and therefore we need to take action. Now, let's look at this with one minor change. Let's change the sample size from 30 and then increase it to 50. So the exact same problem. All we're doing is increasing the sample size from 30 to 50. Now the first thing we have to notice is that there in the red on the left, our standard error changes. Because remember, our standard error is the standard deviation divided by the square root of the sample size. So if the sample size changes, our standard error is going to change. So it goes down. It actually decreases to 276.9. In the previous example, where our sample size was 30, it was 357.48. So increasing the sample size decreased our standard error. So we can go ahead and do the same interval. Now notice that our black lines there are in the exact same place because we still have the same t-statistic of 2.045. But our margin of error decreases. So it went from 700 and something to 500 and something. So we'll go ahead and put our numbers there at the bottom. So again, we just add and subtract. So 4,218.08 is the top of our interval, and 3,104.92 is the bottom of our interval. So, before we look at anything else, just remember, we increased the sample size. That caused our standard error to decrease. So that caused our interval to shrink. Our interval actually sort of moved inward. Now notice the black lines didn't move. What changed is the numbers underneath them in the margin of error. So, we're 95% confident that salespersons spend between 3,104.92 seconds and 4,218.08 seconds interacting with false customers each 8-hour day. So now where's our concern point? Oh goodness. Now our concern point is outside of our interval. And why is that? The concern point didn't change. It's 4,320 seconds, just like it was. But because our margin of error decreased, that means our interval, narrowed, the numbers narrowed, and therefore it kind of moved past our point of concern as it moved inward. Now our concern point is now a t of 2.38. Now remember that the boundary of our curve here, of our area, is 2.045. So this is a t value of 2.38. That is above our interval. So what do we conclude? False customers are not draining our resources from our associates. Policy interventions are not needed. Whoa. What did we do? All we did was change the sample size, and we came up with a completely different conclusion. All we did was increase the sample size from 30 to 50, and therefore our concern point went outside of our area of concern. And the only reason that happened is because the higher sample size decreased our standard error, narrowed our interval, and actually you can think of it as it became more representative of the overall population. There was less error in it, so it shrank, it narrowed around the mean. So, confidence interval, just to review and then we're done. Note that in the examples we use the confidence and interval in the term of plus or minus. When we estimate a population parameter using a sample statistic, it's never going to be perfect. There will always be error. And we just learned that the sample size can greatly affect that error in different ways. There will be a greater margin of error when sigma is unknown given the same sample size. We can express that error or uncertainty using an interval estimate. So we have our point estimate plus or minus our margin of error, which of course is what we've been working with. So our interpretation, again, very important. Remember, the randomness lies in the elements we take for the sample, not in the population mean, which is actually a number that's fixed based on the entire population. It's the probability of obtaining a representative sample. You can think of it as the proportion of samples for which our estimate, the sample mean, is within a certain distance of the true population mean. So you can think of that graph where we had several means in between those two dotted lines. You can also think of it as the probability that the sample mean is within a certain distance of the true population mean. The probability that the sample mean is within that certain distance. The sample mean is either within the interval or it's not. Within the interval or it's not. Now the common error is when students think that the confidence interval is the probability that the population mean is in the interval. So the confidence interval is not the probability that the population mean lies within the interval. It's actually the opposite. The confidence interval is the probability that the sample mean lies within the interval. Okay, so that wraps up this last video on confidence intervals. I might do another one on just working a couple of problems without all the theoretical background and examples and stuff like that. So, just remember there are two types of confidence intervals. In the first case, we know the population standard deviation sigma, and then the other case, which are actually more likely, we do not know the population standard deviation. Therefore, we estimate it using the sample standard deviation. And as we learned in that last example, just increasing the sample size can change the entire outcome of the answer of the problem. So in the next video, we're going to look at how to determine the minimum proper sample size given an interval you are happy with. So if you want to take a sample of all bank accounts, in a region of a bank, and you want to be within $500 plus or minus, we can actually choose a sample size that will give us that within that interval. And we'll talk about how to select that sample size in the next video. So, just a reminder, if you're watching this video because you're struggling in a class, stay positive and keep your head up. You're smart and talented. I have faith in you. Many other people around you have faith in you. So should you. If you like the video, please give it a thumbs up. Share it with classmates or colleagues or put it on a playlist. That does encourage me to keep making them. On the flip side, if you think there is something I can do better, please leave a constructive comment below the videos, and I will try to take those ideas into account when I make new ones. And finally, just keep in mind that the most important thing is that you're on here trying to learn, trying to improve yourself as a student, trying to improve yourself as a business person, and that continual improvement is what really matters. I firmly believe if you have the right learning process in place, the results will take care of themselves. So, thank you very much for watching. I wish you all the best of luck in your studies and in your work, and I look forward to seeing you again next time.